Hello everyone, I'm Paul and today we're solving problem 3147, taking maximum energy from the Mystic Dungeon. This is medium and here I want to show you what's my thought process and efficient solution. This is a nice description, you can read this if you want, but basically we are given an integer array and an integer k. Each value here represents the energy that we can absorb from some magician. And if we decide to absorb this, then we have to move k steps forward. In this case, 3. So from here, we have to go 1, 2, 3 steps forward here. And the total energy, in this case, is given by 5 plus minus 5. So the result in this scenario is 0. If we start here, the current energy is 2. We have to move 3 steps forward, so next we are here. 2 plus 1 is 3, so the result for this scenario is 3. And if we start here, the current energy is minus 10, we move k steps forward, and now we are out of bounds, so the total energy that we can absorb in this scenario is minus 10. Our job is here, we need to return the maximum possible energy we can gain, and the maximum of these 3 values is 3. So we return this in this case. And this is very important. We have to choose a starting point and we have to keep on jumping k steps until we are out of bounds. In this case, next we have to go here and then we are out of bounds. So we can't just return 5. If we decide to start here, we need to continue all the way to the end of the array. Okay? Now there are different ways to solve this, but I think that the following is very interesting and also intuitive. So let's say we are standing at index k. We are here. And right now we have 2 choices. We can take the current energy for a total of minus 5. This means we are starting here. Or we can start at the current index minus k, meaning we can start here. In this case, we will have an energy of 5 plus minus 5, which is 0. And we need to return the maximum possible energy we can gain. So we can store the maximum of minus 5 and 0, which is 0, here. So we are storing the result of this subproblem here, and we are using this for future subproblems. And this is the definition of dynamic programming. So we start from k, from this index in this case, and we move to the right, repeating the same process and storing the result for every subproblem in the corresponding index. So next we are here and we do the same. We have 2 choices. We can start here with an energy of 1, or we can start at the current index minus k, meaning here. In this case, we have an energy of 2 plus 1, which is 3. The maximum of 1 and 3 is 3. Remember, we need to return the maximum possible energy. So we replace this with 3. Now for the result, we need to ask ourselves, what are the possible last values in the sequence? Well, we have this as a possible last value because if we do 2 plus k, this is 5 and 5 is out of bounds. So this is a possible last value. This is another possible last value. If we do 3 plus 3, the result is 6. This is out of bounds, and of course this is another possible last value. So the only possible last values are the last k values. Here are the last 3 values. So for the result, we can take the maximum of these last k values, which is 3. So we return 3. Now let's say we have this input and we do the same. We start from k, meaning here. And we have 2 choices. We can start with minus 1, we start here. Or we can start at the current index minus k. We start here. The energy in this case is minus 2 plus minus 1, meaning minus 3. The maximum of these two values is -1. So we keep -1 here. Finally, we return the maximum of the last k values, the last two values, which is -1. So now I think you get the idea. Time complexity for this approach will be big O of n, because we are iterating every element from left to right. First we go from k all the way to the end, and then we take the maximum of the last k elements. And this is overall big O of n, time complexity. And space complexity, well, it depends on how you implement this. K can grow up to n, here we have the constraints. So if we take a subarray with the last k elements, overall space complexity could be big O of n. And if instead we use a variable to keep track of the maximum value if we are within the last k elements, well, in this case, space would be big O of 1. So it depends on how you implement the code. In this case, we'll go with the big O of n solution. I will leave this to you. So with this in mind, let's go with the code. This code is very short. First we say for I in range, we start from k, and we go up to length of energy -1. And energy at I is the maximum of energy at I and energy at I plus energy at I minus k. Finally, we return the maximum of energy, and we are taking a subarray from -k up to the end. So this is the entire code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.